what we're going to look at is the translation of axes. So we would like to see what happens when we start taking all of these conic sections, circles, parabolas, ellipses, hyperbolas, and just kind of shift them around. How do they move? So the first thing that we want to review quickly is, the first thing we want to remind ourselves is just regular translation. So if I give you a function, I don't know, f of x equals x squared, and I want you, so this is just a graph of a parabola, and I want you to move that graph up or down, what would I do? You guys know? We add or subtract a value to the entire function, right? So x squared plus 4 means you take your parabola and you just move it up 4 units. Or x squared minus 3 means you take the entire parabola and just shift it down 3 units, all right? So what causes a shift then in the horizontal direction? How do I shift to the left and to the right? We add or subtract directly off the variable, not off the entire function, right? All right, so in parentheses, x minus 2 quantity squared, if I subtract 2 from the variable, that causes a shift to the right by 2 units, right? So to sort of generalize that, if we take the point 0, 0, right, or this is the point 0, 0, so I have a coordinate axis, this is the point 0, 0. So let's say I have another point hk that I would like to move, right? So I would like to move point hk to a new point P that is point x prime, y prime. I am moving, well, we're going to say x prime units to the right, y prime units to the top. So translation formulas is that your new x value will be x prime plus h, the amount that was moved. So the original x plus the amount that was moved, and y will be equal to y prime plus k, the amount moved in the vertical direction, right? Or alternatively, x prime is equal to x minus h, or y prime is equal to y minus k. All right, I think this is really sort of best communicated through an example. So let's first look at circles. All right, and I think my circle kind of wrapped around to the previous page here. So first of all, just a reminder that for circles here, a circle has the equation x squared plus y squared equal to r squared, provided that the center of the circle is at the origin. Once we move the center of the circle to a different point hk, the equation of the circle is going to become x minus h quantity squared plus y minus k quantity squared equal to r squared. So we've already seen examples of circles that have been shifted, right? So the center gets shifted. Radius r is going to stay the same. All right. All right, so for parabolas, remember standard form of a parabola, y squared was equal to 4 times p times x squared. But now we're going to subtract hk off of the x and off of the y. So the new vertex then will be located at the point hk. So again, think of this in reverse. If hk is equal to 0, 0, then the equation becomes y squared equal to 4p times x, right? So the focus is also going to shift. The focus, the new focus, if we shift x and our center xy, now becomes hk. The focus will become the point h plus p comma k, all right? So here are the shifts that's going to occur, all right? So for a parabola oriented in the other direction, so if x is our major axis here, the formula becomes x minus k quantity squared equals 4p times y minus h. All right, so here the vertex will be the point hk and the focus will be the point h comma k plus p. All right, so it'll move either up, down, left, and right. All right, so for the ellipse, if we subtract hk from the x and from x and y, instead of x squared over a squared plus y squared over b squared equal to 1, we're going to sort of just really sort of advance that equation to x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. The assumption here is that a is greater than b. And this makes the center of this ellipse the point HK. The major axis is 2A, the minor axis is 2B, right? And then similarly for a ellipse oriented in the other direction where y would have been the major axis, x minus h squared over b squared plus y minus k squared over a squared equal to 1. Here the center is the point HK, and again, major and minor axis, 2A and 2B. All right, so the same shift occurs, same thing happens for hyperbolas. If I want to move it in a direction HK, or move it so that the center now is at the point HK, the equation becomes x minus h squared over a squared minus y minus k squared over b squared equal to 1, center HK. And then similarly oriented in the other direction, if y is the major axis, y minus k squared over a squared minus x over h squared over b squared equal to 1. All right, so more importantly, let's see some examples. You may want to keep these pages handy, because one of the things that we would like to do here is to first describe each curve. We would like to describe each curve first. Is it a circle, a parabola, an ellipse, or a hyperbola? And then go ahead and see if we can graph it. All right, so what do you guys think? X squared over 4 plus y squared over 1 equal to 1 would describe what kind of a shape here? This is an ellipse, right? So first of all, so number 1 here, A, this is an ellipse. All right, B, all right? Let's go ahead and graph the curve. So what I would like to do is, again, I'm just going to rewrite that formula here. So we have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. You certainly don't have to rewrite this equation each time. I just want to do this for comparison. So if you compare it to the function that we have, what is h going to be represented by? So if I rewrite this so it fits this formula just exactly, I will have x minus negative 4 quantity squared divided by 4 can be written as 2 squared plus y minus 1 quantity squared divided by 1 squared equal to 1. And so now we can see the correspondence really clearly, right? So you can just simply read off that h has a value of negative 4, k has a value of 1. So I know now that the center is going to be at the point negative 4, 1. All right. Also, we know that some other things we know. A in this equation is equal to 2. B in this equation is equal to 1. And so let's go ahead and graph. So if I graph this guy, I'm going to draw my axis over here. Here's my XY axis. So my new center is going to be the center HK. It's the point negative 4, 1. So negative 1, 2, 3, 4, 1. So this will be the center of my ellipse. All right, A is equal to 2, so that's my major axis, is equal to 2. So it'll go from negative 4 to negative 2. So let me kind of just draw this as a dotted line. All right. So right here, this is negative 4. This is negative 2, which means this is negative 6. And then my minor axis, B, is equal to 1. So that'll be over here. All right, so here's my ellipse. All right. Any concerns with this problem? Yes? Sure. Yeah. Yeah. So this is the standard form, right? So I would like for my equation to be given as x minus some quantity, right? This is standard form. I need to have this negative in here. But my original problem has a plus. So the first thing that I want to do is write it in standard form. So how can I get that negative in there? I can write it as minus -4. All right, so what I would like to do is once the negative is in there, then we can isolate that quantity and know that this quantity is equal to, well, not A, but H, right? So this quantity here is equal to H. So you can't just say that this is equal to, so H is not equal to 4. It's equal to -4 because the standard form says that this is a negative right here. So that makes that a negative quantity. All right. Does that make sense? Okay. Everybody else okay here? All right, let's look at the next one. Number 2. I have y plus 5 quantity squared is equal to -8 times x minus 2. All right, so first of all, what is the basic structure here? So if you can kind of squint and not look at the shifts, what I kind of have here, it kind of is like a y squared equals -8 times x. Does that help a little bit? It's been shifted though. So before we shifted it, y squared is equal to -8 times x. What is that a graph of? That's a parabola, right? Which way will it open? What is its orientation? Kind of opens to the side, right? It's not going to be like this. It'll be like this or like this if x is squared. But y is being squared, so it's going to be either like this or like this. Since this value is negative, it's probably going to open to the left, right? It's going to open to the left. All right, so first of all, again, I think it's an extra step, I know, but I think it really helps out if we just write down for ourselves just what that the basic function, the standard form is. Just function here. We know that y minus k quantity squared is equal to 4 times p times x minus h. So this just kind of helps when we start comparing. All right, so number 1 in part A here, this is a parabola. All right, B. Let's come up with sort of those sort of common points here. Let me erase that. Kind of helped us just to see the structure. So again, I'm going to rewrite this so it fits this formula just so. So this will be y minus -5 quantity squared equals, so I want to write this -8 here represents 4 times p. If we factor out a 4, -8 can be written as 4 times what? 4 times -2. So 4 times -2 times x minus 2. All right, so this guy right here, the -5, he represents k. The -2 right here represents p, and the +2 over here represents h. So this is k, this is p, and this is h. So we can just simply pull those guys out. All right, so again, I'm going to write that down. So h is equal to 2, k is equal to -5, and p is equal to -2. All right, so the vertex. The vertex is the point h comma k, and in our case, it's going to be the point 2 comma negative 5. All right, the focus. Remember, the focus here, if we have a shift, is going to be the point. So again, just by formula, let me write this because this is a formula in different color for you. H plus P, comma, K. This is where the focus will be located at. So for our problem, this will be equal to H plus P is equal to 2 plus negative 2 is equal to 0, comma, K is equal to negative 5. That's where my focus will be located at. All right, so let's go ahead and graph. There's a coordinate system. We can see that the vertex is located at the point 1, 2, comma, negative 1, 2, 3, 4, 5. This is the vertex. All right, so again, not necessarily drawn to scale here, but the orientation is going to be in this direction right here. All right. So the focus is going to be at the point 0, comma, negative 5. So that'll be right there. This is the focus of the parabola. So if I had asked you to graph the directrix here, where will that be at? So right here, right? It's always on the other side. So this will be the line x equal to 4. All right, you guys okay? All right. All right, number 3. All right, we have the equation y minus 4 quantity squared over 16 minus x plus 2 quantity squared over 4 equal to 1. Again, if you just roughly, so just ignore the translation for a second. Y squared over 16 minus x squared over 4 equal to 1. This is the graph of A. It's going to be a hyperbola, right? So if it's y squared over 16 plus x squared over 4, it's an ellipse. Y squared over 16 minus, if this minus right here tells me that it's going to be a hyperbola, right? Also, since the bigger number goes with the y, it means that the y-axis is going to be the major axis here. So that means that it's kind of roughly, it's going to have this shape. It's going to more or less have that shape, right? So let's quickly see, but it's going to shift. We're going to shift it somewhere else. So let's see what happens here. So here, just for number A, just to kind of answer what is, let's recognize what this is, basic structure. This is a hyperbola. B. All right, so that's standard form of a hyperbola that has been moved or has been shifted. This will be y minus k, quantity squared divided by a squared, minus x minus h squared over b squared is equal to 1. So that's just the standard form. That's the formula that I gave you. So we want to kind of push this guy, make this guy fit into this formula. So if I rewrite it, this will be y minus 4 quantity squared over 4 squared minus x minus negative 2 quantity squared divided by 2 squared equal to 1. Again, I'm going to write the x plus 2 as x minus negative 2 so that you can very clearly see that this negative 2 here, the entire negative 2 represents h. 4 represents k. This 4 over here represents a. 2 represents b. All right, so once we get it in that standard form, it becomes a little easier to pull all of these things out. All right, so what did we say? H is equal to -2, K is equal to 4, A is equal to 4, and B is equal to 2.